Hello everyone, my name is Adrian Alvarez Betancourt and my project is based on the chemical compound hexane and some of its properties regarding combustion. Hexane is C6H14 and we have the reaction equation, and when I balance this I got 2 C6H14 liquid plus 19 O2 gas, and that gives us the product of 12 CO2 gas plus 14 H2O gas plus heat. Then I got the density of 0.659 grams per milliliter, and we assume that the room temperature is 298 kelvin. The atmospheric pressure at sea level is 1 atm. The heat formation for hexane is negative 198.7 kilojoules per mole, and the molar mass is 86.178 grams per mole. Now, in order to get the volume of O2 needed to fully react with 1 liter of hexane, we first have to get the moles of O2. So we go from 1 liter and multiply that by 1,000 milliliters and multiply that by 0.659, and then we're going to divide by 86.178 and multiply that by 19 moles of O2 and divide it by 2 moles of hexane, giving us 72.6 moles of O2. Now, in order to get the volume, we have to mix this formula and we get 72.6 moles of O2. That's what we got here. And we multiply that by this constant, which is 0.08206 liters of ATM, and multiply that by the temperature, which is 298 Kelvin, giving us 1.78 times 10 to the third power of liters. So now I'm going to multiply the heat formation of each chemical compound times the moles of each chemical compound. And so we have 12 moles of CO2 and multiply that by negative 393.5 kilojoules and per mole. And then we're going to add that. We're going to add 14 moles of H2O gas and multiply that by negative 241.8 kilojoules per mole. And we're going to add these two because they're on the product side, and we're going to subtract the reactants. The first reactant is 2 moles of C6H14, and that we're going to multiply that by negative 198.7 kilojoules per mole. And notice how I crossed this reactant over here, is because there's 0 moles of O2 gas, and it will just cancel itself out. So we get negative 7.71 times 10 to the third power of kilojoules. Now, in order to get the heat in kilojoules for fully combusting 1 liter of this compound, which is hexane, we have to again go from 1 liter to 1,000 milliliters. Again, multiply that by 0.659 grams per milliliter. And then we're going to divide that by 86.178 and multiply that by 7.71 times 10 to the third power of kilojoules per mole hexane, and divide that by 2 moles. Now we get 295 times 10 to the fourth power of kilojoules. Finally, we have to figure out the amount in liters of hexane to generate 1 kilojoule of heat. We go from 1 kilojoule and multiply that by 2 moles of hexane, dividing by 7.71 times 10 to the third power of kilojoules, and multiply that by 86.18 grams per mole of hexane, and then we're going to divide that by 0.659 and actually divide by it 1,000 milliliters, giving us 3.39 times 10 to the negative fifth uh, power of liters. By the end of this project, we determined the balance equation for the chemical compound of hexane, as well as the volume of O2 needed to fully react with 1 liter of material. We also discovered the enthalpy of combustion for hexane, as well as the heat from fully combusting 1 liter of material, and the amount in liters to generate 1 kilojoule of heat. Hexane can produce a large amount of heat, making it highly combustible. It has plenty of potential energy that could be used. Here are my references, and I hope you enjoy this presentation.